Okay, so today we are looking at lengths of lines in circles. Okay, the very first rule that we need to discuss is one that you already have. As a matter of fact, it should be in your notes from when we did the definition of a tangent. One of the properties that we said is if two tangents do come away from a common endpoint, or if they originate from a common endpoint, then the lengths of the tangents from that point will be equal. Okay, well, that's the first rule that we're looking at today. Okay, when two tangents originate from a common endpoint, then from that endpoint to the point of tangency on one of them, and from that endpoint to the point of tangency on the other one, should be the same length both times. So that one's kind of obvious, and again, we have talked about it before. Okay. When secants get involved, it changes the game a little bit. Okay. So the first really new situation that we're looking at is when a tangent and a secant originate from a common endpoint. There's going to be a rule, a formula that dictates how these lengths are related to each other. And here's basically how the rule goes. Okay, I've given you just an example that matches this problem. Okay, but let me boil it down for you into plain English. The rule says when you have a tangent and a secant originating from a common endpoint, which is what we have here, one side of the equation is going to deal specifically with the tangent, while the other side is going to deal specifically with the secant. And the rule is going to be whatever the length of the tangent is from the common endpoint F to the point of tangency E, that length is going to need to be squared. Okay, so that's why the formula starts off with the length from E to F squared. The result of that is going to equal, and on the secant, it's a little bit more complicated. Okay, F to G, that is the length of the secant from the common endpoint to the first intersection with the circle. Okay, so the length entirely outside of the circle. That's that first value, F to G. That is going to get multiplied the length F to H, which again is from the common endpoint all the way to the second intersection with the circle. Okay, so with secants, and all the rules we're going to see with secants work the same way. It's the length to the first intersection, and then it multiplies by the length to the second intersection. So it's tangent squared equals length outside on the secant times the entire length on the secant. Okay, the next situation is when two secants come from a common endpoint. And once again, we're going to have a formula that is going to control or organize these pieces of the secants. And if you're able to understand the second half of the previous rule, then this rule basically works exactly the same way. In each of these secants cases, okay, like the top one, okay, the formula starts off here with the length from K to J. What is that? That is the length outside of the circle of that top secant. Then that will be multiplied by K to I, which is the entire length of that top secant. So again, outside times total. And the same thing on the bottom secant, the length from K to L, okay, this is the length outside the circle, times K to M, which is the entire length. Okay, so two ways to really think about it. You can think about it like this: outside length times total length. Okay, some people can memorize it that way. Some people can memorize it by from the common endpoint, you got the length to the first intersection times the length to the second intersection. Okay, and the only other situation we have to look at is with our chords. As you can probably tell for yourself, these are the exact same situations that we have been looking at for the last several days. Okay, lines from common endpoints outside the circle and then of course with chords, an intersection inside the circle. Our discussions up until today have been how do the angles at those intersections relate to the arcs caught between the lines that are doing the intersecting. Today's information is all about what happens with these little pieces of these lines. This one isn't so bad. As a matter of fact, it's a somewhat common sense, but it's just another thing we're going to have to memorize. And basically what the rule here on the pieces of the chords says is, in plain English, the two pieces from one chord are going to multiply together, and that will equal the two pieces from the other chord multiplied together. The product of two pieces from one chord equals the product of the two pieces from the other chord. So all you have to do on that one is just plug it in correctly. It's not a big deal. Okay, let's look at some examples that will put these formulas to work. Okay, you're going to see the same things today that you've been seeing all in the recent days. It's the math is not hard. The formulas are not all that hard. The math is not all that hard. It's just a matter of identifying correctly what's in the picture so that you can apply the correct formula to the picture. Okay, so what is in this picture? What have we got? Not the 2x and the 17s. What? We've got two tangents, okay? Okay, just generically speaking, we have two tangents, and they come from a common endpoint, okay? When this happens, the rule says that the length from one tangent to its point of tangency and the length from the other tangent to its point of tangency should be the same length. So what do you think our equation ought to say? Exactly. 2x equals 17. This is obviously the easiest of any situation that we're going to see today. And then all you have to do is solve for x. What happens next? Absolutely. Divide by 2, and x equals 8.5. Some of y'all got a little weirded out yesterday because decimals showed up on that worksheet. Well, get over it. There's going to be decimal points in answers sometimes. That's just life. Okay. Let's look at one that's a little bit more involved. Okay, now as you can obviously see in this picture, okay, secants and the formulas for secants require more information. So our pictures are going to be more cluttered than they would be with just tangents. Okay. Now, obviously in this picture, we have two secants. The secants come from a common endpoint. Okay, so that means we have a formula that applies to this situation. Okay, and in plain English, the formula reads, okay, pick one of your secants. I'm going to look at this top one. The length of the secant outside the circle, which would be how much? That guy, 6. Okay, that number needs to get multiplied by the length of the entire secant from the common endpoint all the way to the back intersection with the circle, which is why in this case they happen to provide us with that big bridge coming across there. Yeah, that 10 right there, this goofy looking bracket, it was just marking that overall length. Yeah, I just drew it in. Okay. Okay. Now, that is going to equal the exact same procedure applied to the other secant. So what's the, yeah, 5 times. Now, yeah, and it is x. Thank you. Okay, the length of the entire other secant is x. Exactly. Just yeah, clean up the math from there. 6 equals 5x, and as everybody already said, divide by 5. And that one's not so bad either. Okay, it's just a matter of plugging into the secant formula correctly. Yeah. And what you'll see here in a minute is that this easy problem becomes not quite so easy when they shift the position of the unknown. Okay, does anybody have any questions on these two that are up here? Okay, these are pretty straightforward. Let's look at this one. If I had to place a bet, if they were going to ask just one question about circles and the lengths of line segments, I would bet that it's going to be a question very similar to this one. Okay, let's take a look at it. First off, what do you have in the picture? Yeah, one tangent, one secant, and they originate from a common endpoint. Okay, so they're going to probably pick on this one, like I said, I believe, because one side of the formula deals with the tangents, one side of the formula deals with the secant. So you're going to have to know really both situations. What's the formula say? Yeah. The length of the tangent to the point of tangency needs to be squared. Mhm. Yeah, and here's where everybody's going to end up missing it. A lot of people will miss it because they'll forget to square their tangent. Okay, most people that are familiar with circles will get the 4. We will not get this next part right. What is the length of the entire secant there? Okay, 4x. Any other guesses? 4 plus x. Okay, what do you think? Is it 4 times x? 4 plus x? What is it? It's plus. It's two links that are being combined together. It's like driving from here to Dallas and then from Dallas to Houston and then asking how many miles you drove. Do you multiply the number of miles from here to Dallas times the number of miles from Dallas to Houston? No, probably not. That'll end up telling you traveled something like 1,500 miles, and that's incorrect. Okay, you just add them up. How far here and there plus how far to carry on. And that's what people are going to miss. We will not get the 4 plus x part right. So pay close attention if that happens. Okay, what type of math happens here? Let's just start here. What's 12 squared? 144. Good. Okay, what has to happen now? Absolutely. Okay. You can move the 4 to the other side by dividing it right off the bat, but probably the safer thing to do with a whole number is just to go ahead and distribute it. Okay. So let's see what we got there. 4 times 4, 16. 4 times x, 4x. Okay. From here on out, we ought to be home free. Okay. What happens next? hmm Subtract 16. Whatever happens to one side has to happen to the other. 144 take away 16 is, I believe, 128. Thank you. Still equals 4x's, but we don't want 4x's, we just want 1. So divide that 4 out of there. Exactly. If you were joking, it was a good joke. All right, let's look at the only situation that we really have that remains, and that is the intersecting chords. Okay. Intersecting chords is not too much of a challenge. Okay, the rule says when two chords intersect each other, the lengths of the chords will obey the rule that says the two pieces from one chord will multiply together to equal the two pieces from the other chord multiplied together. Okay, so this left-hand secant coming down that way, what are the two pieces? 7 and 8, which will multiply together. Okay, and obviously on the other one, 4 and x. No big deal. All we have to do is just clean it up. What's 7 times 8? 56. 4 times x? 4x. Yeah, only one more thing to do. Get a single x rather than 4 of them. I'm pretty sure it's going to be 14, not 16. So you had a good guess last time and you backed it up with a really bad one this time. Okay. Okay. All right, well, that's pretty much it. The only thing left to do is to take a look at some examples on your assignment.